All right, well, we are going to, this is the introduction in quadratics, and so I'm doing this video so that you can refer to it back throughout the term on this. Maybe you can watch it the first time, and then as we get closer to the test, you can watch it again. So just the few things about to start off is the vocabulary. So here we have the vertex. The vertex is the very tip of the quadratic parabola. This shape right here is called a parabola. The vertex is the tip. Sometimes the vertex is up at the very top, and sometimes the vertex, if it is shaped like that, it will be at the very bottom. So that would be your vertex. The y-intercept, as we know, is where the parabola crosses the y-axis. So if this is the y-axis, this is where it would cross. The zeros is where it crosses the x-axis. So those would also be called the x-intercept and these are also called roots and solutions. So the zero is also the x-intercept, the roots, and the solutions. Those are all synonymous. These are going to be vocabulary words. So that's kind of the beginning of it. And we are going to move on to our first page of notes. So we'll be doing these on January the 13th and 6th or 8th, 17th. So these are the words you need to know. Axis of symmetry. This is the vertical line that divides the parabola. And basically the parabola is just the shape, the U-shape that's formed by quadratic functions. And quadratic functions are basically where you have an x squared. So the axis of symmetry would be the line that first goes straight down the middle. The vertex is the point which is either the highest or lowest, depending. So if the parabola goes this way, it would be the lowest. If the parabola goes this way, the vertex would be the highest. Okay. Then we have the y-intercept, which is the where the parabola crosses the y-axis. Okay, so that is when x equals 0. So when x equals 0, that's the number that the parabola is when it crosses the y-axis. The maximum is the value of the vertex when the parabola opens down. And the minimum is the value of the vertex when the parabola opens up. So it's the y value, actually, the y value. Okay. Then we have our zeros, and these are our x-intercepts. where y equals 0. So you have whatever number that is when y is 0. You have your roots, which are the same thing, your x-intercepts. Value of x when y equals 0. So your number, same thing. And your solutions basically are your x-intercepts. Value of x when y equals 0. So if you notice these three, and your x-intercepts. Value of x when y equals 0. So you notice that these three are synonymous. They are the same. Okay? So when you talk about quadratic functions, there are a few different ways that it is shown. It can be shown as y equals x squared, y equals ax squared plus bx plus c. And we've kind of seen this as standard form. And x can be positive or negative. And let's just say when it's positive, when positive x squared, the parabola will open up. When it's negative x squared, the parabola will open down. Okay. So the value of a, which is, I'm going to go ahead and make this a capital A because that is referring to the number in front of your x squared. Those two things. It determines how wide the parabola is. So you can have a parabola that is nice and wide like that, or you can have a parabola that is steep like that. And the a value makes that determination. And it determines if the parabola opens up or down. So that would be positive and that would be negative. Okay, we're not going to worry about the b. And the c value is where the parabola crosses the y-axis. So this determines if the parabola is going to be up here or down here, where it crosses the y-axis is your c value. That's kind of like, so that would be this variable. So depending on what that number is. So in fact, this one, this equation right here, the c value would be 0. So it would cross, it would stay here. If it was, this might be where the c value is positive 2. So that would look like y equals x squared plus 2. This equation, if this is negative 1, then this equation would look like x squared minus 1, except since it is facing down, this would be a negative. The a would be negative. Okay, moving on. So here are some important questions to know. How do you know by looking at a quadratic equation whether the parabola opens up or down? So up would be like this. Downward would be like this. How do we know that? Well, this would be positive. This would be negative. So this would have it where your x squared, y equals x squared is positive, y equals negative x squared. Which you determine which one is thinner. That is going to depend on the value of a, which is the coefficient. So if I have y equals 2x squared and y equals 5x squared, which do you think is going to be fatter or thinner? The larger the number, the thinner the parabola. I'm not going to fit that. Okay, so the larger number, it gets thinner. So if I have this is my 2x squared, then maybe my 5x squared would look like this. You see how that is thinner? Okay, so the smaller the a value, the thinner. I'm sorry, the wider. I messed that up. The wider. The larger the a value, the thinner. Okay. All right. So if you look at this, if we have to find values, the axis of symmetry is going to be the line where the vertex meets here. So I'm going to just go ahead and write my vertex is 1, negative 4. My axis of symmetry is going to go directly through the vertex. So it's going to be right here. Now we know that a vertical line is x equals a number. So x equals 1. And you notice that 1 is the x value here, 1 is the x value of our axis of symmetry. We have a minimum because there is no maximum. This parabola can go on forever. So since it can go on forever, it is infinity. But our minimum is our vertex. So that will be 1, negative 4. The roots are, remember, we know that these are all the same. So we're going to have the same values for all of these. They might be written a little bit differently. So the roots, the way that you write that is x equals negative 1 and x equals 3. The solutions are going to be in x equals negative 1, x equals 3. The x-intercepts are going to be in ordered pair form. So since I know that y is always going to be 0 for my x-intercepts, I've got negative 1 here, and I've got 3 here. And same with my zeros. They will be written in an ordered pair. So this is where y equals 0. Just like our y-intercept is when x equals 0. So when x equals 0, what is my y value? My y value is actually 3. Negative 3. Okay, so that's how you determine, looking at a graph, and here's the equation. Y equals x squared minus 2x minus 3. Okay. All right. Okay, so to move on and to kind of review a little bit, here is the quadratic function. We have our a, b, and c. We have our x squared, so we know it's going to be in the shape of a parabola. When x is by itself, then it's in the shape of a straight line, but with the squared, we end up with a parabola, which is just basically a U-shaped figure. So on here, on a parabola that opens up, when I say it's opening up, that's saying that basically it's facing the U part is facing the sky. Here, this is the U part is facing the ground. So this is up. Can you see that? This is up. This is down. Okay, so on a parabola that opens up, the minimum or lowest, minimum or lowest point is the vertex. So my vertex is that lowest very point at where the parabola starts to make the turn to the other side. On a parabola that opens down, the maximum or highest point is the vertex. So the very top where the parabola is going up. So if you were throwing a baseball up in the sky, it'd be where it'd meet its peak and then start falling down. The vertical line passing through the vertex is the axis of symmetry. It may be the y-axis, but it doesn't have to be. It's wherever the line is going through the vertex. And the axis of symmetry splits the parabola into 2 equal parts. So it cuts it in half. Alright, so if the graph is going up, then it will have a maximum. If the graph is going down, it will have a minimum. And as we talked about, a 0 is a solution of the equation, the x-intercept, which is the x-intercept. So all of these mean the same. The roots, the zeros, the x-intercepts, the solutions, and the values. So coming back up here, we see that the zeros are where the parabola crosses the x-axis. This is my x-axis. These are my solutions. These are my roots, my zeros, my x-intercepts. These are the same. These have many different names. And all they mean is where the parabola cuts through the x-axis. All right. Okay, so moving on, and if we have a value, if we have an equation like this, we're going to create a table of values, graph the quadratic, and find the vertex and axis of symmetry. One way we can do that is on our calculator. And so I'm going to come down a little bit so you can see. So on your calculator, if you go to here, all right, if I go to and punch in y equals, and then put in my equation. So I've got x squared minus 4x plus 5. So I'm basically just punching in my equation. That's here. Then I can go to, if it says create a table, I can go to second, and right here it says table, and look at a table is created for me. So I can just basically fill in my numbers. It's asking for, so when x is 0, y is 5. When x is 1, y is 2. When x is 2, y is 1. When x is 3, y is 2. And then I can actually, even though this starts at 0, I can even scroll up and it'll give me my negative values as well. So negative 3, y is 26. Negative 2, y is 17. Negative 1, y is 10. So I can basically fill out my table from my calculator. Okay, the other way to do that is by hand, and you could literally just plug in negative 3 or y equals, you have your y equals x squared minus 4x plus 5. I could plug in my negative 3 squared minus 4 times negative 3 plus 5 and do the work that way. Y equals 9 minus plus 12 plus 5, and I would get 9 plus 12 is 21, plus 5 is 26. So I get the same answer, but this one does it for you. Okay? So then, when I go to graph my quadratic, I can just go straight to press graph, and it will graph it for me. Then I can actually look at my graph here, look at my tables, look at my graph, and I can plug in my numbers. When x is 0, y is 5, 1, 2, 3, 4, 5. When x is 1, y is 2. When x is 2, y is 1. When x is 3, y is 2. So I start to see that is where my parabola starts making a turn. Right there. So I can tell that this is going to be my vertex. Where basically the numbers are going down, and then they start going back up where the number starts to, where the lowest number comes, or where it starts to go back up. So my vertex is going to be 2, 1. Here's my vertex right here. And I can tell that from my table because the numbers are going down, 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 and then they start going up. And if I want to make sure, I can go back to my table and scroll down a little bit. So there's my 2, 1. And scroll down and make sure that these are all going to be going back positive numbers. Okay? And they do. So the axis of symmetry, here is your formula for the axis of symmetry. But really, if you look at your vertex, the axis of symmetry is going to be x equals the x value of your vertex. it's going to be the line that goes right through your vertex. Is my axis of symmetry right here. Now I can plug this into the equation where I have x equals the b, so this would be a is 1, b is -4, c is 5. So I could plug it into my equation and say negative b, which would be negative of -4 divided by 2 times 1. And negative times a negative is a positive, so I get 4 over 2. X equals 2. Same thing. Okay. And let's do one on this and then we'll be done. So the zeros, find the zeros. Basically that is the x-intercept. So here is my 0, here is my 0. And you just put them in that way. Your y is always going to be 0. So I got -3, 0, and 0, 0. What's my zeros here, or my solution here? Well, there's only one. It's the vertex. My y is always going to be 0, and it would be -2 is where that is. What about this? It doesn't cross the x-axis at all. So there is no x-intercept. So in that case, you would write no solution. Because it does never cross. There is no roots, no zeros, no solutions. Okay? So now the axis of symmetry, you're going to look to see where your vertex is. Here, the vertex is the y-axis. So your x is going to equal 0. That's my value because my vertex is 0, -9, x, y. That is going to be what I plug in for my axis of symmetry. Here, my vertex is -4, 1. So what's my axis of symmetry? X equals -4. This one, my vertex is 5, -4 is my vertex. So my axis of symmetry is x equals 5, right down the middle. Do you see that? This one's right down the middle. And the y-axis is right down the middle. Okay? Alright. I hope this helped. See you in class.